In today's lesson, we are going to be looking at the sum of squares, or also known as the Pythagorean theorem. So you may have heard of this before. We definitely looked at a presentation in this when we looked at the different math concepts, but now we're going to actually use it and apply it. So if you want, there are a couple videos that you can watch on YouTube. One that kind of goes through some different ways to prove the Pythagorean theorem and some historical and cultural backgrounds of where this idea came from. Little spoiler alert: it didn't really originate with Pythagoras in like ancient Greece. It was actually even earlier than him. So there's some interesting information there in this one, as well as a little bit of background on who Pythagoras was. He was quite the character, and he did kind of come up with a cult, or a math cult, you could say. So some interesting information there about him that you might not necessarily associate with a mathematician, especially an ancient Greek one, or we don't really tend to think too much about who they were as people, and more just about what they contributed to mathematics. So again, you can take a look at those two videos on YouTube. I'm not going to play them here, but feel free to look for them as well, or click the image in the PDF file to take you there. But just as a quick warm-up, if we look at the two triangles below, what do you notice? What is the same? What is different? Right, so just take a second. A couple things you might come across. Again, one's a right angle triangle, one's not. Maybe they all have three different sides, or they all have a long side and two short sides. Say the base is the shortest side. The measurements are all different. You could argue that the measurements in the one on the left over here, they're all off by 1, whereas over here only 2 are off by 1. What if we add some more information to it and give you this now? So the same triangles, but now we've added something different. We've added squares based off of the side lengths. So we have 9 centimeters squared, 16 centimeters squared, 25 centimeters squared, and the same thing for the second triangle. Do we notice anything else now? Anything that's the same or anything that's different? And you might notice that the two sides, 16 and 9, add up to 25. Whereas in the other one, 4 and 36 don't add up to 49. Right? So that is something that's new now that we see with these squares. Right? So the sum of squares talks about any triangle with a 90-degree angle has two sides that, when squared or multiplied by itself, add up to the third side length squared. And then if this is not true, so if we find that this does not work, the angle connecting the first two sides must not be a 90-degree angle. So if we look at our example here, we have a squared plus b squared equals c squared, which is essentially this part here. So 4 squared plus 3 squared should equal 5 squared. 16 plus 9 should equal 25. 25 does equal 25. Therefore, we have a right angle, which we can see. Again, our right angle always denoted by that little square in the corner. We also want to keep in mind, when we're dealing with this formula, A and B are the two sides that connect to the right angle, and C is always the hypotenuse. Right? So in our formula, C is always referring to our long side, and A and B are the sides that are always going to be forming what we believe to be the right angle. We can see in the second triangle, if we try the formula, a squared plus b squared equals c squared, we have our sides. So generally speaking, we would assume that the smallest sides, we have a little typo here, that 6 squared plus 2 squared should equal 7 squared if there is a right angle. we can see that 4 plus 36 should equal 49. 40 equals 49. No, it doesn't. So that means this is not a right angle triangle because it does not allow for this theorem to work. So again, generally speaking, the formula a squared plus b squared equals c squared gives the relationship between sides in a right angle triangle. So again, we can see our formula there. We can see our triangle with the sides labeled. Now what we're going to do is we're going to test to see if triangles are right angles, and we're going to use code to help us. So we're going to look at using some code first to help us, and then we're going to look at doing this by hand as well. So when we're creating a code, we want to think, can we create a set of parameters, or basically a set of rules, that would allow a code to tell us whether a triangle is a right triangle or not? Right, so can we come up with a set of rules? And what would the code need to have as variables? Right, so what would we need to have as variables that would tell us, or that would change each time? So you could think about our formula, a squared plus b squared equals c squared. So we would need to have an a variable, a b variable, and even a c variable. What information will the user have to enter, and how will they know when and where to enter it? Well, we need to know the the three side lengths. So at some point, they're going to need to be told to enter in the different side lengths. And then what will the code do to let us know if the triangle is a right triangle or not? Well, it would need to check a squared plus b squared equals c squared. And if it works, it's a right triangle. If not, it's not. So we would have to get it to say that. So what we're going to do is we're going to use Scratch, which is a fairly user-friendly coding system. It's almost a plug and play. You're not going to be typing any code. But if you click on that link or enter that URL, you're going to get to the home page, and you can just click on the Start Creating. You don't need to create an account or anything. You're just going to click Start Creating. There are some tutorials, but essentially we have pieces on the side with different kind of events or different movements or different codes attached to them, and we're going to basically plug and play or drop plug and play or kind of drop in different parts to create our code. Now, I'm not going to make you come up with this or try to think of this on your own. Again, we're using this formula. I will give you the code of what we're going to need to do. And it kind of follows along what we've looked at. So I'll look at it kind of zoomed in. And again, you can get this in your notes, but this is what our code should look like. So we have our beginning. We're clicking start on our code. And then we're going to say, we're going to see if three lengths form a right triangle. And we're going to ask for the different variables. Right? We talked about we need to know what A is, we need to know what B is, we need to know what C is. Then we're going to tell the code or tell the program to check using those variables, does A squared plus B squared equal C squared? And then if it does, we get it to say that it's a right triangle. If not, then we get it to say it's not a right triangle. So that's essentially what this code is doing. So again, you can try to play around, but everything is color coordinated and kind of plugging in or dropping things in. So we go to our control or the events, and we're going to bring in the first one. So basically this little cat over here, that is what is going to run the code. You can change it to something. I'm going to pick the cat just because for Chester. You can choose any other kind of spirit, as they call it, that you'd like. Realistically, if you play around with this more, you could draw specifics or draw your own. So there's really lots you can do. So we have our cat, and we are going to get it to say, so if we kind of scroll through for purple, we want it to say, if, for example, we said say hello, if we clicked on the green start, we would get our cat to say hello. And it would say that for 2 seconds. That's what our code is saying here. But we don't want it to say hello, we want it to say we are going to, we are going to see if 3 lengths form a right triangle. And we'll change it. We'll just put an exclamation mark, right? So we can see our cat is now saying what we're going to do. Now, we need to get our cat to ask, or our spirit to ask. So we need to find out 3 variables. So we need to enter length of side A, and then we're going to wait. Here is where we have a variable. So we're going to introduce set variable. Oh, but we don't have a variable. We need to come up with one. We see we have one here. We need to make a variable. We're going to name our variable A. So we have one variable, A. We're going to set A to, now we don't want it to 0. We want it to something else. So we're going to go back to sensing, and we're going to put in an answer bubble. So we want the cat to ask us for an answer. So for example, if we press play, we're going to see what forms, enter side length A, and we see now we have an option to enter our answer. So say we can enter 4. And we now know that A is 4 up here, so it's keeping track for us. But again, that's the end of the code, so there's nothing else we can do. We're going to ask it to give us something else. So now we're going to say ask enter side, or enter length of side B, and wait. We need to get a variable. So now we're not setting A because we need a new variable of B. So now we're going to set B to not 0. We want it to change, so we're going to come up with an answer. So set B to answer, or another answer. And we're going to repeat the same thing. We need to ask it. So again, now we're going to ask enter length of side C. And we're going to set that to another variable. We need a new one, in this case C. So now we have that, except again, we don't want it to set it to 0. We need to set it to an answer. So you can see that the little 0 kind of highlights. That means I can drop this in. So now, when we run our program, we're going to see enter side length, say 4. Enter side length, and 4, 5. So we kind of missed one at the beginning, so we don't have anything entered there. So we would need to kind of adjust that with our code. We can maybe change that. Say we would want it to be 3. Just because we forgot to put something in there. But again, our code ends. It's not doing anything. So now what we need to do, we need to include an if statement. So if we go back to control, we want the if, then, and then else. So basically, if something works out, then we say something, and if not, we have something else. So what's going to work, let's put in what we want it to say first. That's easy, because we already know what we want it to say. So say, it is a right triangle. And if it doesn't fit our formula, we want it to say, it is not a right triangle. So now we need to get it, or we need to enter our formula to get, or to allow the program to calculate to see if it works. So this is where it gets a little tricky. So we're going to have one shape because we want it to equal something. We don't want it to equal a number though, so let's delete the number. Now we want it to equal c times c. So if we go up over here, we have our operators. So I can multiply two numbers. So I'm going to click on the multiplying one, drag it in, and I'm going to go back to my variables. I'm going to drag in c. Oops, what happened? Maybe I have to do it in parts. So c times c. I'm going to drag the whole thing. There we go. So it might take some playing around. Let me move this whole thing up and over. Oh, I put it behind. So again, right? Sometimes it just moves things around. So now we need to fill in the first part. So now we need it to have two things added together because we have our a squared plus our b squared. But in each part, I need to have a squared. Now this is where it gets a little tricky. You want to be careful that when you're highlighting the box that you want to replace it with. So now I have something times something plus something times something equals c times c. All I need to do now is throw in my variables. Again, making sure I highlight the correct thing. Oops, I did not do it there. B and B. So now I have a times a plus b times b equals c times c. And it's going to pull my variables from the answers that I give my cat. And if it does work, then this is what it should be. So let's stop and let's run our program from the beginning. So enter side length A. So if we go back to our example, the one that we know for sure, we can say that one side length is 3, side length B is 4, side length C is 5, and our cat says it is a right triangle. That works out. Let's run it again, but using the other measurements to see if it works. So we have 2, we have 6 for B, and C is 7. It is not a right triangle. So now we have our cat that will run this program for us, and we can use this anytime we want to check to see if it is a right triangle or not. And you've just successfully coded a small program to basically run Pythagorean theorem. So now anytime you're given a triangle, you can check. Right, so there is a checklist that you can go through, entering in the numbers, running your code to see if it is a right triangle or a non-right triangle. So again, I will let you try this part on your own. Again, hopefully you're able to go through the code and find everything. Again, you can just double check the video. And again, you can double check or try this on your own. But we're going to move on to trying to look at doing this by hand. If you do want to level up, try to see, or challenge yourself, try to see if you can use the code that finds a missing side of a right triangle if we only know the values of, say, C and B, and we're looking for side A. So see if you can come up with a way that figures that out. But we're going to test this by hand. So we know how to, we have a code now. We know how to do this using the code, but let's say we don't always have our computer handy, we don't have the code nearby. How would we do this by hand? So, again, we're going to basically be doing the same thing that we just did with the code. We know we're starting with a squared plus b squared equals c squared. If we look and we have a triangle that has 3 sides, 5, 12, and 13. Let's assume it's forming a right triangle. The longest side should be 13, and then 5 and 12 should be the other sides. and then it should form a right angle if it does work. Using Pythagorean theorem, let's enter in our values. So we know A is 5, or it could be 12. It doesn't really matter which one is A and which one is B. 12 squared, and then C squared should be 13. So 25 plus 144 should equal 13 squared, or 169. And we get that 25 plus 144 is 169, which does equal 169. So this does work. This is a right triangle. So now again, this is an opportunity for you to practice, to try on your own. Again, you've done an example using code. I want you to try to use or do it by hand to test to see whether they're right triangles or not. You can always go back and refer to the code as well if you'd like, just to kind of verify your answers. We'll go through the first one together. So 6, 10, and 12, again, assuming the longest side should be our 12 squared. So 6 squared plus 10 squared should equal 12 squared. 36 plus 100 should equal 144. But we know that 136 does not equal 144. So this does not work. So therefore, it is not a right triangle. So again, there's 3 other examples. I do recommend that you pause the video to try this on your own to see, again, just get used to using Pythagorean theorem to practice verifying for right triangles. So coming back to our test, we should find that the middle 2 are right triangles and the first and last one are not. Just again, just some small clarifications. Just make sure for the third one, you put 25 meters as the hypotenuse or the C value. Because in order for our triangle to work, the right triangle or the hypotenuse or that C value has to be our longest side. So that means that 7 and 24 should be our 2 legs or our 2 short sides, or A and B. Right, so again, when you're making this test, make sure that the longest side is your hypotenuse or C value. Units don't really matter because, again, we're only worried about the actual number. So again, it doesn't matter what the units are. That doesn't change what the rule is. So again, when we're finding side lengths, this is the second part of what we can do. So this was the challenge that you had to code, but we're going to look at how to do it by hand. So once we do it by hand, maybe this might help you go back and figure out how we can do or use the code. So if we know 2 sides in a right triangle, we can substitute into the sum of squares formula and solve for the third side. So we are going to be substituting and solving. So we are going to be going back to our equations kind of unit. Remember that A and B always represent the legs or the short side, and C always represents the hypotenuse or the long side. Right, so again, just referencing that. Now you want to be careful because some letters or some diagrams may use different letters. That doesn't mean that they're wrong. It's just different letters or labels for the side. But when we're using our formula, we want to stick with A squared plus B squared equals C squared. That's why it's important to remember what A and B represent in terms of the short side and C being the long side. So if we look at one example, we want to find the missing side length. So this one is relatively straightforward because we are looking for C, which is our hypotenuse. That means our other 2 sides are A and B. Again, it doesn't matter which one is which. So we're going to start off with our formula. A squared plus B squared equals C squared. I'm going to plug in or substitute my values in. So 20 squared plus 21 squared equals C squared. Now I'm going to start to calculate. So 20 squared is 400 plus 21 squared, which is 441, will equal c squared. 841 equals c squared. Now I need to solve for c. I don't have c squared yet, or c yet, I have c squared. So essentially what I have is, oops, if I do quick drawing of my triangle, I have this area. I have this entire area of a square coming off of that hypotenuse. I don't want that entire area though. I want the smaller side. I just want the side length. So how can I get rid of this squared? What do I have to do to get rid of this squared? Well, if we go back to our solving equations unit, we would do the opposite operation. And the opposite of squaring something is the square root. So if I take the square root of both sides, the one side it'll cancel out the square, and the square root of 841 is 29. So that means 29 is the length of my hypotenuse. So for B, same idea. Try to solve this one on your own. Again, using the same idea, plugging it into formula and solving for c squared. So again, or c. So again, it's going to be the same idea as the example we just did. So if you have to refer back to it in your notes as an example or a template for the steps, that's fine. So coming back, if you successfully plugged in your values and solved for c, you should find that the side length is 14.9. Or you might have gone 14.866, but rounding to one decimal place, we have 14.9. Again, A and B doesn't matter which are which, again, because they're both legs, and it's not going to affect the operation. The next example, this one is looking where we're missing a leg. So now we're missing side B. So the other side that makes up the right angle has to be A. That means our other side has to be C. Another helpful hint, the side across from our 90-degree angle is always going to be the hypotenuse. So in this case, 30 is our side C. We're still going to treat it the same way. We're going to start off by using our Pythagorean theorem formula. A squared plus B squared equals C squared. The only difference now is we're substituting into different spots. We're still substituting in for A. So A squared we can replace with 24 squared plus B squared, still unknown, now equals 30 squared. Now here what we can do, we can go through and we can calculate. We can calculate what 24 squared is. 576 plus B squared equals 30 squared, or 900. And now I want to get B by itself. So I need to get rid of this number of 572. So I'm going to use opposite operations, and I'm going to subtract 572 from one side, balance it out by doing it on the other. One side cancels out. So back to our solving equations unit. We're then left with B squared equals 900 minus 572. We get 328. Now we're down to the last step of trying to get B by itself. Same thing that we have to do, we have to square root. So you're going to find that every time you're using Pythagorean theorem, the last step that you should be doing should be square rooting. So we're left with B equals the square root of 328, or 18.1 rounded. So that is our missing leg or missing side length. So slightly different formula. When we're not finding the hypotenuse, we do have to do some subtraction. So there's this one extra step here. So this step is extra compared to the last two that we did. And you are going to see that's the difference when you're trying to find the leg. Now, it wouldn't matter if it was A or B that you're trying to find. It's still going to be the same idea. just depending on where you plug or substitute the numbers in. So we have one last example, same idea. All right, I'll help you out a bit. Even though we've labeled this x, there's still the understanding that this is considered a leg and 15 is considered a leg because these two sides form that right angle. And that means that 20 is considered our hypotenuse, or C value. And again, it's also across from the 90-degree angle. So now with that information, try to go through and see if you can solve for that missing side length or that missing leg. So if you plugged in everything correctly and you went through the same steps, you should find that the missing side length is 13.2. Again, that is rounded. And there are a couple things that you can do to kind of briefly verify or just do a quick check to make sure your answer is correct. Or at least on surface it appears to be correct. So again, we're talking about the different side lengths. We should know that the hypotenuse is the longest side, or we've mentioned that in definitions before. So the hypotenuse is the longest side of our triangle. That means the two legs need to be less than 20 meters, or millimeters. A is 15, that's less than 20. B we found out to be 13.2, which is also less than 20. So that's a quick way that you can verify if your answer makes sense. So right now our answer does make sense, so maybe we might have made a calculation error, but again, that would be more on us. Using the formula, we could see that we've done everything correctly, so this does make sense. If we were to go back up to, say, another example where we're finding the hypotenuse again should be the longest side. My two legs are 14 and 5, which are both shorter than 14.9, which is what we found to be the hypotenuse. Now it's close. It's relatively close to the same value, but again, the C value or the hypotenuse is larger. So that's all that we're looking for on the surface level to see if our answer makes sense, which in this case it does. And again, trusting that we went through the formula correctly, this would be a good answer. So again, the main things from this lesson are how to use Pythagorean theorem to find or to verify if a triangle is a right triangle, as well as using it to find different side lengths, whether it's the hypotenuse or the legs. We also looked at a little bit of coding on how we can kind of work through the steps to create a program to kind of go through and do these calculations for us. But again, the main thing is just what is Pythagorean theorem and how we can use it in the different ways.